Have you wondered how wind turbine blades are tested?
You and I have an insatiable appetite for electricity. Come with me and we'll look at the issues relative to wind farms and the communities that they serve. This is the Windfarm Guy.
Hi, this is Dennis Stout, and thank you for joining me for this episode of the Windfarm Guy. Today I am in Boston, Massachusetts, and I'm here at the Wind Technology Testing Center with George Blagdon. He is the technology director.
Technical manager,
thank you, here at the facility. George, thank you for joining us. Tell me about where did this begin? How long has it been here, and what was the purpose?
Sure. So we've been here for 10 years now. We commissioned in May 2011, and really the impetus for the construction of the facility was the need for large full-scale testing in the United States. There was a small sister site in Colorado, and that could only handle blades up to 50 meters. So it was known that as the blades got bigger and bigger, we needed a larger facility, and so that's why we were built. Our funding background is a little bit federal government and a little bit state at the time. It was about 60-40 under the American Recovery and Reinvestment Act. And then the remaining 40% came from the Massachusetts Clean Energy Center. All right.
Is it still about the same today?
So we're unique when it comes to when you look at a federal lab, or even not a federal lab, a government-backed lab, where our operations are covered with our testing expenses.
Sure.
So our testing revenues actually cover our day-to-day operations.
That's right.
So we don't have any sustaining funding from the federal government.
Right, because you have companies, turbine manufacturers, that bring you their blades, pay you to test them,
Exactly.
And that way they're getting the value, but they're also paying you to do that.
Exactly.
To run those tests.
We are a commercial facility. Yeah.
Nice. Okay. And how long does it take to test a blade?
So nowadays it's between 6 months and a year from when we receive the blade till it's either sent out or decomposed of.
Okay.
And that's comprised of, so we do structural testing. I think that's one of the misnomers, and I get a lot of calls often, is we are doing structural testing. We're not doing aerodynamic testing. So our sole purpose is to put the blade structure through a series of tests that determines if it's strong enough to be on the machine. And so that consists of static tests, which is a bend test. We're actually just bending the blade, and that's to mimic a 50-year wind load case. And then we do fatigue testing, which is actually shaking the blade back and forth for millions of cycles, months at a time, to mimic 20 years in the life of the turbine.
That's right. So these turbine blades are designed to last 20 years, and they live their 20-year life in less than a year.
Yes. Yeah. We beat
You're
it up
kind of brutal
good.
to them, aren't you?
We beat it up pretty good. Yeah. So we're taking, on a turbine, it might see, but the load case might be 20 million, 30 million cycles. We're reducing that by a factor of 10 to 2 million cycles, which increases the load quite a bit more than a factor of 10.
How many blades have you run through here so far?
We are just about 50 blades now.
50.
Ranging from our smallest at 40 meters to our largest with the 107 meter Heliade X machine from GE.
Wow, and that's a big blade.
It was quite a big blade. Our facility can handle about 85 meters, and so that 107 meter blade we had to cut.
Cut the end of it off.
Had to cut the end off, bring it in, test it a little bit different, but still in the end the same way.
Right. Okay. And so how many people does this operation require to test this?
Yeah, so one of our target goals from the beginning was to stay as lean as possible, so we can adapt quickly to customers as they come in. And right now we're operating with 9 full staff members, comprised mostly of engineers, our executive director, and a technician.
Right.
So we're quite lean. And the only way we can do that is by cross-trained, hands-on people. If you look at me today, I'm a little more dirty than I'd like to be, but sometimes it's what it requires to
You do what it takes, right?
Yeah, exactly.
How many blades can you test at a time?
So we have 3 test stands inside, and full-scale blades we can test 3 at a time. But if you notice in the pictures, we have some space, so we do additional subscale testing. Subscale and subcomponent. There's a slight difference there. And that allows for a customer to test a research and development idea a little early on before they put it into a full-scale blade.
Sure. Now, as you're testing these, and you're whipping these blades around pretty good, but you add, before you do all of that, you add sensors.
Yeah.
Is that right?
Yeah, so each full-scale blade typically has between 200 and 300 strain gauges, and they're applied individually by hand and then wired back by hand. There's no automation there. So it's quite a labor-intensive process, and it needs to be very exact as well.
Right.
Because that is we're backing out loads from those strain measurements, and that's how the blades are certified, is those loads.
Right. So you have computers and software that monitors all of that data coming in. And how often did you say that the data points are?
Sure. So right during a fatigue test, we're running at about 100 hertz. So that's 100 data points per second.
Per second.
Yeah. During a static test, we'll run about 10 times that, around 1,000 hertz, to pick up anything happening even faster.
And with 200 to 300 sensors, that's an enormous amount of information.
It's quite a bit. Quite a bit of data.
Wow.
Our engineers are very good at data analysis and data reduction.
Sure.
From
sure.
high fidelity data.
Wow, that is great. If you like what we have discussed today, be sure and click like and subscribe below. If you have something that you would like to comment on, or a topic you'd like me to address relative to wind farms, please also leave me a comment. George, thank you very much for joining us today. I sure appreciate it. This is amazing, and I really appreciate you showing me around and me being able to see some of the tests that you're doing on these blades.
Yeah, thank you, Dennis.
And it serves a great purpose for the industry. Thank you very much.
Thank you.
All right. This is Dennis Stout, and I'm the Windfarm Guy.
Thank you for watching. Working together, we can make good energy decisions and save our planet. I am the Windfarm Guy.